Good afternoon. We're going to go ahead and get started. Without any further ado, here is Kelly Kuhn.
All righty. Fantastic. So I'm here to talk about Priuses today. No. I don't recommend you do this with your Prius, though. Anyway, so hybrid jokes aside. I'm sure, wow, this is going to be I kind of want to just go out there and sit down with you guys at a table. Hybrid instrument, I wanted to define that real quick. It's, yet another marketing buzzword because we don't have enough of them. But essentially for us, a hybrid instrument is something that can both scan and survey. Right now, there's actually quite a lot of these instruments out there, varying levels of capabilities, and we'll talk about why this is interesting or important in a bit, but just wanted to kind of lay that out. And usually they kind of come in two flavors, right? There's either scanners that can kind of survey, or there's total stations that can kind of scan, right? And so they tend to come in those two flavors, but I personally, at least, think this is a very important trend in the industry, and there's some reasons behind it, and that's what we're here to talk about today. So you guys get to listen to me whether you like it or not. Actually, you can leave, right? So, Josh just did, so why not? Now, the funny thing is about these is that different people react to them differently. So I love seeing the reaction. So this one happens to be a TopCon hybrid instrument. Because you talk to scan techs and they hate having to carry two pieces of equipment, right? So if you've got a scan tech that's going out in the field and they're running a total station to set up control and then they're having to run a scanner, they get really excited about these because they're like, you mean I don't have to carry a total station with my scanner everywhere? And that's nice in theory. And then you talk to surveyors and they just don't like laser scanners most of the time. And so to them, they're just like way more comfortable with the idea of a total station with a scanner on it. It's kind of funny. I don't know. I just think it's odd that it somehow pleases both parties. Usually they don't agree, right? So it's kind of funny to me. Here are various different versions or flavors of said hybrid instruments. Trimble's got a couple. They kind of have one of each of the two categories I tossed out earlier. TopCon technically we have a total scanner that can kind of survey as well, but that's kind of our newfangled thingy. And then we've got, of course, Leica's got a couple as well. I don't think actually anybody, maybe Regal has something that's similar, but they probably do. They have something for everything with an extra zero on the end of it. So, but this is the problem. Does anybody remember these? Yeah, well, bugs, yes, but also it was a terrible phone, a terrible fax machine, a terrible copier, and a terrible printer, right? And so this is like the fear, right, that you have to watch out for with the instruments. We're not going to dive into specific instruments and pros and cons because that's not what the point of today's conversation is. But just fair warning, not all instruments are created equal, and most of them will suck at one of the other thing, right? You'll have a really good, solid total station that will suck at scanning at 10,000 points per second, and good luck with that. But yeah, there are some that are better than others. But why is this happening, right? This to me, I think, is the important thing to discuss, or perhaps the alternate phrasing of the question, why should I care about this? So basically, it's just how our industry is trending. So you see I've got little 5 bullet points up here. Typical size of scan jobs declining, even though we're doing a lot more scanning. Frequency increasing, like all of this stuff. This is kind of interesting happenings in our industry right now. I could also bring up probably another one, which is like the transition to mobile scanning from terrestrial scanning. That probably should factor in here as well. But let's kind of hit some of these. So size of scan project. So Actually, the US IBD does surveys, and we collect data on the industry. And so something that's really interesting to me is that over the last 5 years, and actually we can even go back 9 years, and kind of look at information we're getting back from our surveys. And for a long time, the size of scanning jobs were increasing, right? It's like, the average scan job started out at like 50 scans or 25 scans because each scan took like, an hour and a half, right? And then all of a sudden, scans took 5 minutes, and we were like, what the flip? We could do 100 scans, right? But I think the type of work that we're all doing, there's kind of new use cases and workflows that laser scanning is going into, and those are starting to maybe not replace the traditional, one and done, go in, scan 1 million square feet and build a model or CAD drawings from it, that kind of as-built workflow. But now we're seeing a lot more construction QA, QC stuff. I mean, Josh's presentation earlier, like, they're going out there and scanning on that project all the time. They're doing 5, 10, 15 scans, and the scan job's done. So it's a very different model. And so it's like all of a sudden having a scanner that can scan in 45 seconds versus one that scans in 1.5 minutes, who cares? It's only 15 scans, right? There's other things that are actually driving productivity in the field. But we're seeing this on our data. Like the average size of scan jobs on the reported, like the typical job was less than 100 scans. Like, that's crazy to me, but that's what we're seeing. And this kind of already talked about the frequency side of it as well. You can't go out and scan the concrete on every level because it's not all poured on the same day, right? So this is a challenge for our service providers in the room because, unfortunately, construction project schedules are not perfect, and none of us like getting the call at 4 o'clock in the morning that the concrete got poured 3 days late and they need you out there for the post-pour scan in the next 30 minutes because they're going to start putting things back down on that slab, or start their post-pour shoring. But so this kind of frequency and speed needing to get out there is another driver. And then localization's a big thing. How do you do construction QA/QC if you're not on a coordinate system? Well, you have to guess which things were built correctly and visually line the scan up to those things and hope you're not wrong. That's a terrible workflow. And so coordinate systems are just becoming more important. It's not like, I built an as-built model. They'll figure out the coordinate system later when they hire a surveyor to do the civil engineering work, right? We kind of need that. And then in general in the industry, I mean, Philip's presentation talking about photo documentation. Contextual data is becoming more and more valuable and more useful. And there's all these tools in the cloud that let people consume that data in lightweight formats, whether it's photographs, whether it's laser scans, whatever. And so capturing that data and having that as additional documentation is super useful. And right now, I mean, photo documentation is certainly winning that battle, but that's because it's a lot cheaper and quicker to do that kind of capture. But that's also something that's going to be changing over time. Prices of LiDAR is coming down. We have, silicon photonics, little chips. You're starting to see, I don't have my iPad with me, but it has a little time of flight sensor in it. So all of this stuff is changing, and we're going to start to see those kind of hybrid instruments also going out to the field and supplementing that photo documentation and making it LiDAR again, right? And then, of course, digitalization, right? Layouts getting digitized, has been digitized. Fabrication is digitized. Installation is not really digitized yet, but there's a lot of push for it because that feeds into progress reporting. Validation is digitized. And so there's all this stuff. So all the little PLSs that we see out on job sites, right? The plumb level square lasers that are out there that are analog instruments right now. Like, they're even building apps for those now so that you can tie them into digital information. And so they're trying to make those analog devices digital. Only works moderately well. But we're starting to see things like total stations, for layout being replaced by other interesting things. Like, I don't know if you guys have seen the Litex doohickey that's basically a laser projector on the job site for layout. Super cool. Of course, everybody's seen the little robots that draw the stuff on the ground. I think it's funny that you make a digital robot that then draws an analog line on the slab. It's kind of quaint. And then, of course, Hilti's got their little poke holes in the ceiling bot. And that's, I don't know, it's an interesting thing to see this kind of digitization, all these different, oh, I can't walk away from the microphone, all these different trends, but they're all kind of coming back to this change of capture out on the job site. And so whereas 5 years ago when I was in the industry, most of my jobs were big as-built jobs, and then we started doing some construction validation. We're talking to service providers that are doing a whole lot of validation work, doing a whole lot of small jobs, and this kind of shifts what instruments are optimized or relevant for the job site. If you got to go crank out 250 scans, you're going to buy a traditional terrestrial scanner, or actually you're going to go buy a VLX or something like that, and you're going to go scan that as rapidly and quickly as possible. But if you've got 12 scans and you need it registered in the field in real time because they want to get you their floor flatness results while the concrete is still wet so they can go fix it before it hardens, you don't have to go back to the office to do the registration. You want to tie into survey control while you're out there on a job site. And that is the modality that terrestrial scanning is moving towards, in my opinion, is that terrestrial scanning instruments like the VLX, mobile scanners, are rapidly approaching the point where they're good enough to replace an RTC 360. Like, why would you take an RTC 360 to a job site when you have a NavVis VLX unless the accuracy requirements are really high, right? So much more efficient. And so, I don't know, I think it's kind of an interesting position for our industry to be in, and that's really what I want to do with the rest of the time, is just talk with, all 5 of you. Because, this is what I'm seeing. I'm curious if y'all are seeing something similar, but I don't want to be like ding dong, the terrestrial scanner's dead, but I kind of feel like ding dong, the terrestrial scanner's dead. It doesn't make sense to make a 4 million point per second terrestrial scanner. Who gives a crap? I don't know. Scott, what do you think?
I'm not ready to say it's dead at all, but I think your USIP survey that shows fewer scans per project is definitely, that's consistent with our experience, for sure. Sorry, I don't think you have anything important to say. You definitely don't want to record it, but I agree with that entirely. Mainly, that might be because we do a lot of mobile scanning, and our terrestrial scanning is, establishing slam anchors for that, and we don't necessarily need that level of accuracy and resolution for a lot of what we do, at least in the architectural world. I don't think they're going away anytime soon in terms of deviation analysis and modeling pipes and feeding into edgewise, even though y'all do unstructured support. But still, I think it's still got a role for that. It's just shifting,
Yeah, and I mean, there's applications where it's still necessary, right? But I think also, though, it's probably a matter of another generation of sensors before mobile scanning is giving data that's comparable to what you can get out of a terrestrial scanner. That's probably one more generation of, the next Velodyne puck or the next whatchamacallit puck. And so it's interesting. It's not dead today, but it's like, if I'm starting up a shop tomorrow, I'm not buying a high-end laser scanner, a terrestrial laser scanner. I'll rent it when I need it. But it's like, I'd buy one of these hybrid instruments and a VLX, if I started a business tomorrow, because that gives me my anchors and it gives me my control with the hybrid instrument, and then the VLX gives me my productivity, and I can do 90% of the work that I'd be contracted to do with, 98% with those two instruments, a hell of a lot cheaper than I could with, an $80,000 laser scanner. And I don't know, it's interesting. To me, it's interesting. That's because it's all been about the terrestrial scanner for the last decade. It's all been about how do we make it faster? How do we capture more data with it? How do we do this? Like, how do we eke a little more productivity out of that thing? Put wheels on the tripod, do this, do that. And now it's just like, who cares?
This total non sequitur, but have you seen that little robot painter thing in action?
Yeah.
Have you ever seen a construction site that has a floor that tidy?
No.
Yeah.
So I will say, the little robot painter thing, it does a pretty good job even on dirty floors. Like, they've done a pretty good job with it. But I don't know. To me, that's it's kind of like investing in a high-end terrestrial laser scanner right now. It's like, why that when we're probably 3 to 5 years away from accurate enough augmented reality? So just wait a couple years and then buy the next version of the HoloLens, and the lines are drawn for you, by the thing that you're wearing on your hard hat rather than by a robot on the ground. But
I agree. People are slow to adopt, though.
they are. And that's the irony, right? It's like, they'll probably have that technology. I mean, shoot, Trimble just announced their MX, whatever, their mixed reality layout solution. And it's a combination of like a total station and HoloLens. So they're doing some kind of active tracking, I guess, of the HoloLens, of the headset, using the total station so that they can get accurate positioning. And then your layout is literally projected in front of us. This is like supposed to launch in June or July of this year. I was like, super cool. But it's going to take like 10 years for companies to even, seriously adopt that. But yeah, so I don't know, but it's just interesting. I don't know. That's what I wanted to talk about today, though. Is like, do you guys see how about y'all? Do y'all see the same thing? Are y'all seeing, think terrestrial scanning is maybe not quite dead yet? Oh man, I should have gotten that GIF. I'm not dead yet. Donk.
Yeah, in my opinion, I don't think it's dead yet. I think we've been using, I work for Langen, we've been using like the Navis and stuff like that, and I'm seeing great things with it, but it's with the applications where, all right, they just need something real quick. It's within 2 inches, they're happy. That's a great product to use for that. But when you get into, we do a lot of plumb surveys.
Yeah,
that's not going to help us out with there. You're still going to have. To me, the Navis or the Go Slam, they're just another tool in the toolbox that's going to help us be able to finish the job that we need to get done.
Mm-hmm. Yeah. So you think scanners have more legs on them for a little longer?
I think so.
All right. I give them 3 years. It's a tripod, 3 legs, 3 years.
Hey, I
right?
like it.
What about y'all?
But
Mm-hmm. Yeah. Yeah. Well, that's it's interesting, and yeah, I'm being a little bit, how should we say, hyperbolic, but sometimes it's fun to be a little hyperbolic to, drive out conversation. Sure. But yeah, it's I don't know. I think we're at one of those inflection points in our industry where I really am thinking that I don't know exactly when it'll happen, but over the next couple of years, I think we're going to see sales of terrestrial scanners hit a peak and start to decline as mobile scanners are able to supplant more and more and more of the use cases that terrestrial scanners used to be necessary for. And then at the same time, we've got this kind of new class of instruments that are coming out that are solving a different niche, and that niche is actually, from what I can tell, the most rapidly growing niche in our market, which is this kind of continuous capture modality, where you're scanning every day or you're scanning every week, and you don't need the density of an RTC 360. Or you don't need the, you know, and a lot of times you don't need the accuracy either. You know, you're needing something that's plus or minus a couple mils is good enough. And you know, you don't need something that's like Nat Sass. You don't need a surf phaser, that's for damn sure. Yeah, all right. Well, unless you guys have any other comments or heckling, or the mic's right there. All right. Well, then I'm done. Oh yeah, the Litex. Dude, I love those guys. It's so cool. So, not to be a product pitcher for another person's product, but in this case, so the laser that they're projecting is also ranging. So they first draw the line, and there's a little correction. So it traces the outline with the laser tracer, and then, which is a couple of spinning mirrors in there, but then they're also ranging, and when there's deviations in the range, they then correct and modify the line. So if you have like a dip in the concrete, you don't get a curved wall, you get a straight wall. And so it's just super cool. Yeah, yeah. And so it's really interesting. And then, and it, you know, the range isn't very large. Like, you know, you're not laying out 30 meters away from this thing. You're laying out like within like 5 to 10 meters, right? I think their max range is like 10 meters or something, right? So it's you know, you pick it up and move it to get the other part of the walls. So it can either do a control points, so you can have it shoot a control point, or you can use surfaces. So again, because it's a measurement unit. So for instance, if you have like a floor plan with walls that you load into their software, you can actually say, you know, here's that wall, localize yourself, here's the floor, localize yourself, and it'll do a relative localization, which for a lot of interior layouts, good enough. Like, you don't need to geolocate your electrical outlet, last I checked. Yeah, exactly, basically, off surfaces, presuming they're built correctly. And if they're not, you get a variance, and you can decide if it's too big or not, you know? So, super cool product. Really, really like their stuff.
And the one on the left is looks like a healthy, and that's a core drilling thing on the bottom up.
So it's a embed. It drills embeds.
Okay.
So rather than, you know, the traditional workflow here, right, is plywood down, embeds placed from above, pour a concrete strip for them, hope the embeds are still visible. Try and find them. In this case, it's, just pour the concrete and then take this robot in. Our little Hilti total station will track it. So you localize the total station, and then it tracks the robot, and then the robot goes and drills all your embeds for you. Yeah, and it's like, it's the Hilti compression anchor or whatever, blah, blah, blah. So, you know, it does the thing and does the, you know, and they're there. So, but it's just an interesting solution, you know. Probably not as efficient or effective as what we're already doing, but it's still an interesting solution. Oh, yeah. No, you just pick it up and carry it on your back. Yeah. No, good luck getting that up a 2x4 ladder right on a job site, the airplane. Yeah, I think they rent them locally. I don't think you buy one, but yeah, fun stuff. So, all right.
All right, well, thank you very much. Thank you, Kelly.
Thank you, guys.